Today, let's have a look at trig equations. It's very important now to solve these. One of the things you need is a scientific calculator, a good one, that will actually help you and assist you in actually solving trig equations. Just a couple of things. You've got your three trig functions that appear on your calculator, but you don't have the other three, that is sec, cosec, and cot. And we'll talk about that when we get to the types of equations that have got those. But it's very basic stuff. What you've learned so far is that straightforward punching of your calculator from sine 40 is just straightforward. Sine 14 gives you 0.64 rounded off to 2 decimal places. What it actually means, you must remember, this means that there is an angle of 40 degrees somewhere in a right angle triangle whose ratio is 0.64. And if we were to bring that to a triangle and just draw a rough triangle for that, you'll see that actually, what it means is that the ratio we're getting there from our calculator is, if we roughly write it as a proper fraction, is 64 over 100, which is 0.64. That means that's the opposite side to the angle and the hypotenuse. So that's what it gives us. So that's what you would normally get if you just punch an angle with your trig function. But your equations are asking for something different. Here's another example there of 1069 degrees giving you 2.61. Your equations are asking you to give us this angle if we give you this ratio, which is different. And here now the punching of your calculator is going to be different. You need to use the shift button that you can see there in order to punch with your trig function. And we'll see just that now. Cos x is equal to 0.51. There now we do not have an angle. So in this equation, we're being asked to determine or solve this equation by finding what angle would give us a ratio of 0.51. And this is where now your punching of the calculator is slightly different. Where first you have to press shift and then press the trig function and then press the value on the other side. And that will then give you, once you punch your equal sign, the angle that you needed to solve for in your equation. So in this case, the angle was 58.34 degrees rounded off to 2 decimal places. So that's roughly what you need to know when you're solving trig equations. But just take one important thing and make sure that you understand this. Whenever we get to this step of using a calculator, it must just be the trig function and the angle and the ratio on the other side. That's very important, because when you get your equations, that's the step you always want to get to before you use your calculator. So let's go. Let's look at some examples. Solve the following equations. We get an equation of sin theta is equal to 0.987. This one is pretty straightforward. It's ready for a calculator. So we punch shift sin and we get our 80.75 degrees. Another one, 3 cos beta plus 2 is equal to 3.738. Now this is not ready for a calculator. That means we need to get rid of that plus 2. We need to get rid of that 3, so that we're left with only the trig function and the angle equals to a ratio on the other side. Hence, you have to apply your knowledge of equations, use additive inverse, negative 2 there on the other side would end up giving us 1.738. Divide both sides by 3, you end up with 0.579. And then this step, now we're ready for a calculator. And there is your calculator angle after punching shift, cos, and the value on the other side. Here's another one. Again, simple manipulation of things there. Get rid of the positive 2. Additive inverse is negative 2. Divide both sides by negative 2. Watch out for signs. We end up with a positive 8.54. Now we're ready for a calculator. Just be careful on this step. There are people sometimes who make an error. They think now they can divide both sides by this 3. You can't. This 3 alpha is actually your angle, and be comfortable with it. It means that now you just need to go punch your calculator to get your angle. And then once you've got your angle, you are still using that angle that you had in your equation, which is 3 alpha. Okay, it's an expression that represents the angle we're looking for. So we divide both sides by 3, and there is the actual value for alpha. Very, very important to watch out for that. Here's another one, 2 sine theta. Again, divide both sides by 2. Now we're ready for a calculator, and it's straightforward. But now, what would happen when you punch your calculator? You'd actually get an error. That's because there's no solution. I want to take another one because I want to illustrate this with both of these. This one is cos. Again, if you try to punch a calculator here, you'll have a problem. Now notice very carefully the values on the other side. That's 2.2, that's 2.59. Hey, our solutions would lie between or from the values -1 up to 1. So beyond positive 1 and below negative 1, the trig function sine and cos are not defined. You can take that when you do trig graphs later, you see it even more, but I'll show you in a trig graph what this looks like. In a trig graph, it looks like this. The yellow graph there is your cos graph, and then the other graph is your sine graph. Look how the maximums and minimums of those graphs go. The minimums are both at -1 and the maximums are both at +1. Nowhere beyond those values or below -1 do you see a graph, meaning the graph is not defined there. There's no value of y that would be linking up with any angle there. So as a result, when we get equations, our equations reach a step where they represent a basic sine graph or a basic cos graph, as I've shown in the diagram, and therefore any values that fall outside this range of theta or x or whatever angle you're dealing with, being from -1 to 1, those values would be will be undefined, and basically they won't give us a solution for the equation. Hence, you would need to write no solution in cases like that. Just keep an eye on equations of that sort. Let's get more examples just to create other scenarios. Here we've got sine theta plus 20 degrees is equal to 0.84. Watch out again. Just like my previous example of 3 theta, our angle is theta plus 20 degrees. It's just that it's an expression with more than one term. Be comfortable with it. Okay, and don't start now using the 20 degrees and doing all sorts of things. There is a stage or a step where now you can use that 20 degrees. So as it is, this one is ready for the calculator. We've got a trig function in the angle as an expression, and we've got a ratio on the other side. We punch our calculator, we get what we call an angle that comes from the calculator, or the calculator angle. And now that means we're ready. And notice on the left hand side, we still got our angle that was an expression. So now we've got a nice linear equation that you can solve, and then you end up with your angle there for theta of 35.49 degrees. Very easy, but remember, your angles can also be expressions with more than one term. Okay, here's another one, but now this one needs to be manipulated a bit. Divide both sides by 5. Notice that I have not simplified square root 3 over 5, because square root 3 is an irrational number. It's going to have a whole lot of digits after the comma. So I do not want to lose the accuracy of my answer. So what I do in that case, I keep my answer, my value there is square root 3 over 5, and not simplify it. It is sometimes allowed that you can simplify, but you then have to round off the decimals you get. So I'm avoiding that. I'm keeping it as square root 3 over 5, and then punch my calculator, because this step is now ready for the calculator. So shift 10, and then the values on the other side gives me a more accurate angle, because I've used square root 3 as is and not rounded off. And then transpose the -44, and then divide both sides by 2. There's your answer. And then here's another example. Notice something here. They didn't give us the actual ratio. They gave us 10-20 degrees. Now, you could either do one of two things here. Divide both sides by 2. Remember, we're 2 there. And then punch your calculator as is. And this is, again, to be more accurate in terms of the decimal digits that you have in your calculator. And you punch it as it is, shift cos, and then 10-20 over 2 in brackets. And then you'll be fine. The calculator will give you that calculator angle, 79.51. Now solve, and you end up with 99.51. It is also allowed that if you want to, you go and simplify that 1020 over 2. And if you do that, you'll get that. But now you have to round off your digits. Now, sometimes you can just keep them on your calculator whilst you're doing calculations in order to keep your answer, in fact, as accurate as possible. And you then punch shift cos in that value, and then you get your angle, and then you still get the same answer. Okay, sometimes it might be slightly different because of the rounding. For instance, somebody is rounded off maybe to 2 or 1 decimal place. So always watch out for that. When you're trying to be as accurate as possible, try and keep the digits on your calculator, or use a better way of punching your calculator without simplifying the expression you had. Here's another one, cot 2x, and notice now cot. Now this is one of the reciprocals, and we know cot is a reciprocal or an inverse for 10. Now there is no cot on our calculator, as you saw earlier when we were showing you the calculator. So how do you deal with these kinds of equations? Well, it's simple. If you just change cot to 10, just invert the other side. Can you see where it's 0.839 over 1? So now it becomes 1 over 0.839. And that's what you would always do when you change any reciprocal to either tan or sine or cos. Okay, and then you're ready for the calculator. Punch your calculator, get your reference angle or your calculator angle, and then you divide both sides by 2, and there's your answer. X is 25 degrees. Here's another one. Cosec alpha is equal to 5/2. We can't punch a calculator just yet. Once we've fixed it, change that cosec to sine, we also have to change the value on the other side to its inverse, because we've substituted the left hand side with the inverse, so we have to invert the value on the other side, giving it its inverse as well. Now we're ready for the calculator, and then our answer, 23,58 degrees. Pretty easy. One other thing, always make sure that for South African schools, your calculator is on degrees. You'll see a D at the top on the screen there on your calculator, and not be busy working things out and yet using radians, which are used in other places. But for our South African schools, we use degrees.